There we go. All right. Hey, I need something to write with. Hey, but we're talking about percent yield. The very last thing that we're going to talk about before we walk into that quiz on Friday. Now, I will say there will be a handful of percent yield questions on the test. Will they make up a majority? No. Will they make up a sizable minority? No. You're going to get like 2 or 3 questions about percent yield. If there's one thing that you should absolutely come prepared with on Friday, is your steps for stoichiometry and also knowing your mole map. Identifying your given, excuse me, your given side, how I get from my given side to my desired side through my mole ratio, how I can be given mass, volume, particles, how to convert them to the moles, to multiply across the mole ratio, to get my final mole, to convert it into which product I need. Do I need my final answer in mass? Do I need it in volume? Do I need it in particles? That is going to be the biggest hurdle that you're going to have to jump. I'm not saying that the smaller hurdles aren't important. I'm just saying if you are pressed for time and you're like, man, Mr. Wiseman, I'm so cooked. I'm going to get flamed on this test. Come with those 2 things. And for the most part, you'll be fine. Percent yield. Thus far, calculations have assumed that the reactions go to 100% completion. However, in reality, reactions are influenced by many external factors. In most cases, reactions will never get to 100% completion. This causes the mass of the products formed, the actual yield. So what I'm making, how much I make, is my actual yield, to be less than what is predicted by my stoichiometry, which is my theoretical yield. Those were our 2 vocabulary terms that I told you we were picking up today. There's one more later. A quantity that describes less than ideal yield is known as the percent yield. How do I express that quantity? I express it through a ratio. What is my formula for percent yield? Right here. Actual yield over theoretical yield times 100%. Fun fact, you've actually been using the same equation for years if you're doing your own math for your grades. Let's say I just took a quiz and I got a 40 out of 45. I got 40 out of a possible 45 points. And when I get home, I know Mom is going to ask me, what'd you get on that test? Now, some of us might be going, well, I got a 40 out of 45. Mom don't know what that is. What's that 40? What's that do? What's percentage points? How's that work out? Well, I don't know. We got 40 out of 45. I'm going to show you how you fix that. You're going to take the actual value that you got, your 40. You're going to divide that by the most amount of points that you could get, 45. And you're going to multiply that by 100%. So I have my 40 divided by 45. Multiply by 100. I'm going to get a percentage. And I can tell Mom, I got 89%. That's all you're doing with percent yield. The only difference is instead of being told that this is the theoretical yield, we're going to use stoichiometry to figure out what that is. You're going to be given your actual yield. Let's look at an example together, because I am all for examples. I need to determine what the percent yield of H2O if 138 grams of water is actually produced from 16 grams hydrogen gas and excess oxygen. Now, to help us along with this, I've already balanced the equation that we're going to need. So, two hydrogen gas molecules are going to interact with one molecule of oxygen gas, and they are going to yield 2 molecules of water. Or 2 moles of hydrogen gas react with 1 mole of oxygen gas to yield 2 moles water. Question. From the 2 numbers in my question, which one am I going to use for my theoretical yield? Am I going to use 138 or am I going to use 16? Which one do you think? Do you think option 1 or option 2? And we'll do this by show of fingers. Now, of course, if you think it's option 1, give me a index finger. Do not give me this finger. That's just uncalled for. If you think the answer is number 2, then we're going to use number 2 for our theoretical yield. Give me option 2. What do I think? What number will I use for my stoichiometry question? 1 or 2? Show me a finger, guys, or show me 2. Okay, got a couple ones for 1s, got some 2s. What are we thinking? All right. 2, all right. Okay, Jackson, pick one. 1 or 2. All right, Derek. Thank you very much. Thank you, Marisol. The number that we're going to use here is number 2. Are produced from. That's my cue that I'm using 16 grams for my stoichiometry. So I have my balanced equation. In this reaction, am I going to worry about excess oxygen? Nope. I'm going to eliminate it altogether. I don't care about excess oxygen. I got it. I got excess of it. I can't measure excess. It's like telling me a number for infinity, which is odd. Because when you get to physics, you find out some infinities are bigger than other infinities, and it gets trippy. But that's a whole nother problem for a whole nother day. So I'm going to start off by converting my 16 grams of H2, 16 grams H2, into moles. What's my molar weight? My molar mass for H2. Right there. What's the and then there's some paper with your name on the back. What is the molar mass of hydrogen? Someone shout it out to me. Was it? 1.01. I have 2 hydrogens, right? Multiply that number by 2. That gives me 2.02, right? 2.02 grams hydrogen gas. Now, I see that my given is my hydrogen gas and my want is water. Looking at my balanced equation, how many moles of water do I form? 2. Form 2 moles H2O. Looking at my balanced equation, how many moles of hydrogen gas do I need? Was it? 2. For every 2 moles of hydrogen gas, I will form 2 moles of water. Now here's the thing. I need to figure out grams. So I need to convert my mole water to grams. I know the molar mass of oxygen is 16.00, top of my head, because I've been staring at it for so long. And trust me, guys, I never expect you guys to memorize any of the elements' molar mass, so I give you a periodic table every time. I just have a brain that when I have a bunch of numbers rattling around my head, they just stick for no reason. So 16 plus 2.02 gives me 18.02 grams water. And if I do the math for that, 16 by 2 plus 2 divided by 2, 18.01. I'm going to get a number that looks like this. 144.08. Is that my final answer, though? No, we know it's not my final answer. How many sig figs did my question start with? Start with 2, right? 1, 2. That means my answer could only have 2. So it's going to give me 140 grams H2O. This is my theoretical yield. This is if everything goes absolutely right. The stars and the planets align, and I have a completion of this reaction. 16 grams of hydrogen gas in excess of oxygen gas will yield 140 grams of water. Now, like I said before, we know that's never possible. There will never be a situation where you get absolute 100% yield of something. So now we move to the percent yield. The actual yield is what I actually got. I was able to get 138 grams H2O from this experiment. Had everything worked out, I should have gotten 140 grams of H2O. So I'm setting up my problem. I have my actual and I have my theoretical. The last bit, the icing on the cake, is I'm going to multiply everything by 100%. So, if I take 138, I divide that by 140, I'm going to get this long number. I'm going to multiply that by 100%. Et voila. I'll give it 98.57, blah, 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 blah. Here's the thing, though. My sig figs, when I'm multiplying or dividing, I go by the number with the less amount of sig figs, 140 has 2 sig figs. 138 has 3 sig figs. Therefore, my final answer will only have 2 sig figs. So, if I have 98.57, what's my final percentage going to be? 99. 99% is my final answer. All we're doing is we're adding one last step. I'm going to kick myself because I leave my lunch on the counter. Cannot stay cold if it's on the shelf. All right. Boom. Does anyone have any questions about how we got this far? All right. Let's try to do number 1 together. So we have some practice problems. First thing we want to do is we have an equation. Lithium hydroxide plus potassium chloride will yield lithium chloride plus potassium hydroxide. Is that equation balanced? Is your equation balanced? Just by eyeballing it, we should be able to say, hey, yeah, I got 1 lithium, 1 lithium. 1 hydroxide group, 1 hydroxide group. 1 potassium, 1 potassium, 1 chlorine, 1 chlorine. Another way I can tell something's balanced just by looking at it. If I look at question 2, what do I see? I see coefficients. If I see coefficients, I know it's balanced. I can just do a quick eyeball because we've been balancing equations for weeks, going on a little more than a month now. I kind of just do a quick look. Hey, that looks balanced to me. Perfect. We're moving forward. I began a reaction with 20 grams of lithium hydroxide. What is my theoretical yield in grams of lithium chloride? So if I'm worried about my steps of stoichiometry, step 1's already done. I have my balanced equation. Step 2, I need to identify what I have, what I want. What does the question give me? What do I have from the question? 20.0 grams of my lithium hydroxide. I'm trying to figure out how many grams of what that I form. What did my reaction yield? Lithium chloride. All right. So, looking at my step 2, I check off step 2. I've rewritten my question. I have what's given to me, what I want. I will tell you this. A lot of people make the mistake on the quiz and will be on the test. If you're not doing step 2, you're liable to mess yourself up. There's a reason why I want you to rewrite the question. And so you can clearly see what you have, what you're going for. Step 3, I need to convert my grams of lithium hydroxide, 20.0 grams lithium hydroxide into moles. Now, I know from doing this for so long, I know that lithium has the molar mass a 6.94. What's the molar mass of oxygen? Look at your periodic table. Don't look at the board. It won't help you on that one. 16.00. What's your molar mass of hydrogen? 1.01. So, that means the molar mass of lithium hydroxide is 23.95 grams. 23.95 grams lithium hydroxide. If I were to weigh out 1 mole of lithium hydroxide, I'd have to weigh out 23.95 grams to get 1 mole of it. Now, that's step 3. Step 4 is what? What do I do at step 4? I gave you step 1 and step 1, 2, and 3. What's step 4? The ratio. Which ratio? Starts with an M. The mole ratio. I have to multiply by the mole ratio. I have lithium oxide in my numerator. I want to get rid of lithium oxide. Moles. From my balanced equation, how many moles of lithium hydroxide does my equation need? From up here, how many moles of lithium hydroxide is in my balanced equation? 1. I want the moles of lithium chloride. My balanced equation, how many moles of lithium chloride do I have? 1. Now remember, I want to convert this to grams. Could someone tell me what the molar mass of lithium chloride is? (42.39). 6.94 for lithium. Oh, sorry, the glare. Plus 1 chlorine, 35.45. Gives me 42.39 grams lithium chloride. Now, if I solve for my problem, I multiply all my numerators together. Then I multiply my denominators together. Then I'll divide across my fraction line. I'll get 20.0 times 1 times 42.39 divided by 3.95. 1 times 1. I'm going to get 35.398 blah, 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 blah. Now, here's the thing. My final answer can only have how many sig figs? Two? 3. Remember, 20.0. So I have 3 sig figs here. So I draw my rounding line between the 3 and the 9. Does the 9 push my 3 to a 4? So my final answer is my 35.4 grams lithium chloride. That tells me my theoretical yield. Question 2. I actually only produce 6 grams of lithium chloride. What is the percent yield? So I have a numerator, I have a denominator. I'm going to multiply that by 100%. What number is going to be my numerator? 6.00 or 35.4? 6.00. Why? Because it said actually produced. Actual yield, actually produced. They go hand in hand with each other. 6.00 grams of lithium chloride is my numerator. What's my denominator? 35.4. If that's the case, 6 divided by 35.4, multiplied by 100%. So give me a long number of 16.949. Blah, 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 blah. I don't care about that. How many sig figs can my final answer have? 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Is the 4 big enough to push my 9 to a 10? No. That means that my final answer is 16.9%. I've seen worse yields before. I've done worse yields before. Getting a less than ideal percent yield is expected. If we have time towards the end of the year, I think I have a yield lab that we're going to do where some of us are going to get a yield of over 100%. Just so you can see that there's a lot of factors that you cannot eliminate. That's going to be after SOLs. My goal. We'll see if I can get to my goal. I want you to try to do question 2 by yourself. Propane plus 5 moles of oxygen yields 3 moles of carbon dioxide and 4 water molecules. If I start with 5 grams of propane, what is my theoretical yield of water? I'm going to put a timer up for 5 minutes. And I want you to take a stab at it. We'll come back to it together. I'm not going to just leave you there by yourself with it. But I want you to take a chance. That gives me a chance to fix my grade. Not grade. get through 2A, see if you can try to do 2B, where the actual yield is 1.5 grams of water. What is the percent yield of the reaction? Only if you get that far. We'll get there together if not. All right. Okay. So, I have my balanced equation. How do I know this? Just by looking at it. Coefficients. Anytime I see coefficients, balanced. So, I have 5 grams. So, start off with 5 grams. So, 5.00 grams propane. I need to figure out what is the theoretical yield. Now, one may be a little confused on what the theoretical yield is. It's always going to be grams. Every time we talk about theoretical yield, it's always grams. I want to figure out percentage of grams water. So, first thing I do is I start by writing up my equation. 5.00 grams C3H8. Multiply that in order to get 1 mole C3H8. Pull up my handy dandy calculator. Make sure it's on. I have 3 carbons. Carbons is molar mass of 12.01. And I have 8 hydrogens. Remember, I always want to be adding them together. So give me a molar mass of 44.11 grams propane and propane accessories. Nobody? All right, I see how it is. Tough crowd up there. I have 1 mole of propane. How many moles of water do I have? 4. So, rewrote my problem, converted my given to moles, multiplied by the mole ratio. So step 2, step 3, step 4, step 5. What do I need to do? I need to convert my moles water to grams. So like I said, for water, as we did earlier up top, we already did water. 18.02 grams H2O. Take out my handy dandy calculator. Times 1 times 4 times 18.02. Divide that by 44.11. Times 1 times 1. Close parentheses. I'll get this run on number. 8.1704 blah 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 blah. How many sig figs can my final answer be? How many did I start off with? How many sig figs did I start off with? 1 or 3? Start off with 3. Therefore, my final answer I need 3. So I draw a rounding bar between my 7 and my 0. Is my 0 big enough to push my 7 to an 8? And this is my final answer. It's 8.17 grams H2O. That is my theoretical. My theoretical yield is if everything goes right and happy and hunky-dory, I should get 8.17 grams water. But I'm like every other chemist out there. I do not get 8.17 grams. Instead, I get 1.5 grams water. In this situation, which one's my numerator? 1.5 or 8.17? 1.5. Why? Because again, it says my actual yield or actually got, actually this. That's always my actual yield. Theoretical yield goes on bottom. 1.5 divided by 8.17 times 100. 18.359, blah, 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 blah. How many sig figs can my percentage be in? How many sig figs can I have? 2. So what's my final answer then? 18%. Some questions like question number 3, I will just tell you what the theoretical yield is, what the actual yield is. So you could just do the, so for the equation. What I want you to do, oh, that's right, I figured as much. You're going to finish questions 3 through 9 for homework tonight. What you're going to do, give me a quick second. What you're going to do on Friday is that when you walk in, you're going to drop your percent yield paper into the bin, and I'm going to grade it while you guys are taking the test. Now, I saw a hand from Janelle, and I saw a hand from the third row. So I'll start with Janelle. What's up? Sure. Person in the back. What was the rule? Sure. Question. Were you going step by step and then rounding the entire way?
No, I was like, when I did the algebra,
All right, well, let's check one more time. So I start with 5, right? 5 times 1 times 4 times 18.02. I hit enter, gives me 360.4. I hit divide. Now, I want to make sure I have everything in parentheses because I want to multiply all my denominators together. I have 44.11 times 1 times 1 times 1 times 1. I close parentheses. It happens. But in that situation, you'd only get 1 point off because I see that you understand the concept. I understand you followed the process. We are human. You're gonna make a bad hit in the calculator once or twice. It's okay if you don't catch it. You write your answer down. I understand. We have anxiety. We're pushing for time. There's lots of factors going on. But if you show me the process and notice that how I was going through the process, I was also labeling what everything was. I want us to get used to that. Because if it's a situation where I just forgot one, you were labeling everything else. I'm not going to break the bank on you for that. We're pressed. We have anxiety. It's a time test. I get it. Walk me through the process. So you'll finish questions 3 through 9. And what we're going to do for